Hello everyone, I am Deepika Ainapur from ECE department from KGDD College of Engineering and Technology. Welcome to one more session of probability theory and stochastic process. In the last session, we have discussed the basics of probability theory and stochastic process. Now, and also we have discussed about the important concepts like joint probability and conditional probability. Using those concepts, we will be deriving two more probabilities, that is total probability and Bayes theorem. These two things we will be seeing today, total probability and Bayes theorem. Yes. So, any time, any concept when we are learning, we have to understand why we are learning that concept. So, why we have to study the concept of total probability, when this total probability will be useful in the applications. So, all these things we will be understanding now. For example, we know about the conditional probability. Yes, if you don't know this concept, you can even watch it in the previous video. So, conditional probability, I have told that probability of A by B. So, probability of A by B is nothing but I am finding out the probability of A given B. That means already B is given to us and we are finding out the probability of A. And A and B are the relative events. They are both related to each other. A, that is nothing but after the completion of event B, then only the event A will take place, right. So, probability, conditional probability is given by probability of A pipeline B. This we can also, it is defined as probability of AB into probability of B. Like this we will be defining the conditional probability. Now, if one particular event is dependent on multiple events, it is dependent upon the multiple events of a particular experiment. Then for example, this event A is related to B1, B2, B3, P4 up to Bn. Then like event A is related, maybe it is related to B1, maybe it is related to B2, maybe it is related to B3, maybe it is related to B4. Up to Bn, any of the events it is related. Then also we have to define the conditional probability, because after the occurrence of these events only the event A will take place. So, probability of A by Bn. In this manner, we will be defining the total probability of A by Bn. That is conditional probability. In this manner, we will be defining the conditional probability. Now, yes. Now, for example, conditional probability, for example, I will take it as B1 as one of the event, B2 as one of the event, B3 as one of the event, right. So, B1 like some of the events, for example, if I have taken the complete total probability which I want to find out is nothing but the student has arrived to the college. This is an example which I am taking to make you people understand about the total probability concept. So, A event is nothing but the student has arrived the college, right. So, for this the student might have taken any of the means to arrive to the college. For example, B1, B1 is nothing but, I'll take like student might have taken the college bus, right. The student might have taken the college bus and then arrived to the college. And B2, the student might have gone to the bus stop and taken the RTC bus and then arrived to the college. B3, the student must have booked the cab and then arrived to the college. And B4, the student might have taken his or her bike and then came to the college. So, after the occurrences of these events only, this event will take place. After the occurrences of these events only, this event will take place. That time I have to find out the total probability of A, because the A is dependent upon many events. A is dependent upon B1, B2, B3, B4. Like this, A is dependent upon multiple events, right. For one more example, which is related to electronics and communication engineering. For example, I want to, if I consider A event as amplification of the signal, right. So, I am considering A event as amplification of the signal. So, amplification can take place by any of the means. For example, we have different types of amplifiers: common emitter amplifier, common collector amplifier, common base amplifier. Any of the amplifiers can amplify the signal. So, first event I will consider, like for example, if I am using CE amplifier and amplifying the signal, and second event I will be using CB amplifier and amplifying the signal. Third event I will be using common collector amplifier and amplifying the signal. That is, any of after using these amplifiers only, the amplification of the signal is possible. After the occurrences of B1, B2, B3, then only A will be occurring. So, I will be deriving the equation, complete equation for the total probability A. So, now we know the importance of total probability. By using why we have to study about this total probability, I will be deriving the equation for the total probability of A, right. So, I am taking for example like this, that is B1, B2, B3, B4 up to Bn. All the events I am taking on a sample space, and these are all mutually exclusive events. All these events B1, B2, B3, B4 up to Bn, they are mutually exclusive events. Like this, I am just writing it on the sample space. So, up to Bn, just I am representing all the events on a diagram, like on a complete sample space. I have to find out the probability of A. Probability of A is related to any of the events, right. It can be related to B1, B2, B3, B4 up to Bn. Any of the events it is related to. A event is related to any of the events B1, B2, B3, B4, B5, B6, B7 up to Bn. So, now this is the complete sample space. How I can write this complete sample space? This complete sample space is nothing but it is the union of all the events of B. So just I will be writing it as n is equal to 1 to n, right? N is equal to 1 to union of all the events. So Bn, that n can be anything from 1 to n, it can be anything. So complete sample space I am defining. Complete sample space is equal to union of n is equal to 1 to n Bn. Like that I am defining the complete sample space. Now for example, if I want to find out A, only A from this sample space, it is nothing but it is given by the A intersection S. If I find out the common element between A and sample space, I will be getting only the A. So just I will be substituting A intersection. So sample space is nothing but union of n is equal to 1 to n Bn, right? A is equal to A intersection union of n is equal to 1 to n Bn. Now can I just take it out, that is union of n is equal to 1 to n A intersection Bn. So just if I take the probability here, probability of A will be equal to probability of union of n is equal to 1 to n A intersection Bn. So just I will be taking union outside. So it will be just probability of A intersection Bn. So from the conditional probability formula, we know that whenever it is probability of A is related to Bn, just I will be applying the conditional probability formula. So union, I can just write it as summation of n is equal to 1 to n probability of A by Bn into probability of Bn. Probability of A is equal to summation of n is equal to 1 to n probability of A by Bn into probability of Bn. So like this also we can write the total probability of A, right. So this is the definition for the total probability of A. This is the complete definition of the total probability of A. Total probability of A is given by summation of n is equal to 1 to n probability of A by Bn into probability of Bn. Like this we will be defining the total probability. That means A is related to n B events, n events of B. So we have to find out the total probability in that case. That is the reason we are just finding out the total probability. Now from this we will be deriving the equation for the Bayes theorem. Now Bayes theorem, why we have to go for the Bayes theorem? For example, in the conditional probability, we have probability of A by B, but sometimes we want already probability of A by B is given, but we want to find out the probability of B by A. that time we will be going for the Bayes theorem. So, just I will be writing the conditional probability equations, same conditional probability equations we will be writing to find out the Bayes theorem. So, probability of A by B will be equal to so just consider it as the equation 1. So, this is nothing but conditional probability. Here probability of A we are finding out given the probability of B. So, probability of A by B will be equal to probability of AB divided by probability of B. In the same manner, probability of B by A will be equal to probability of AB divided by probability of A. Consider this as equation 2. Now, from these equations, can I write the equation for the this? I will be using this equation and this equation, and I will be writing the equation for the probability of A by B, right. So, probability of A by B will be equal to what I will do in the place of probability of AB, I will substitute this probability of B by A into probability of A. So, probability of A by B is equal to probability of B by A into probability of A divided by same thing probability of B. Probability of A by B is equal to probability of B by A into probability of A divided by probability of B. In the same way, I will write the equation for probability of B by A in terms of first equation. So, probability of B by A will be equal to what is probability of AB? This one, right. Probability of AB from the first equation, it is probability of A by B into probability of B. Probability of A by B into probability of B. So, from this equation just I have written this and divided by what? Same thing, this equation we are using. So, it is probability of A. So, just we have written the two equations for the conditional probability. So, same conditional probability concept we have used and we have written the two equations. Probability of A by B is equal to probability of AB divided by probability of B. In the same way, probability of B by A is equal to, you can write it as probability of AB or probability of BA. So, probability of AB divided by probability of A. So, probability of, just I have used this equation, second equation I have substituted in the first equation in this equation. So, probability of A by B will be equal to probability of B by A into probability of A divided by probability of B as it is. And here I have taken this equation and substituted the first equation here. So, probability of B by A is equal to, just take this equation, probability of A by B into probability of B divided by same thing, probability of A. These two equations are also, like we can call here only because these two equations have not substituted still, but these two equations are nothing but B by A is given and we are finding out probability of A by B, and A by B is given, probability of A by B is given and we are finding out the probability of B by A. So, that is why Bayes theorem we will also call it as reciprocity theorem. Reciprocity theorem. That means what? Whenever probability of A by B is given, we are also finding out probability of B by A. So, this is the reciprocity theorem. Now, we have the total probability concept. Just we have to substitute the total probability because A is related to multiple events of B. So, we have to find out, we have to substitute the equation for A, that is probability of A. Probability of B by A is equal to probability of A by B into probability of B divided by complete total probability of A should be substituted. So, summation of n is equal to 1 to n probability of A by Bn into probability of Bn. So, in this way we will be finding out the Bayes theorem. In the same way you can even find out for the probability of A by B. We have to substitute that time the total probability of P. So, this is the formula for the Bayes theorem, or it is also called as reciprocity theorem. Bayes theorem is also called as reciprocity theorem. So, yes, in this like incomplete we have discussed about the total probability, and we have also revised some concepts about the conditional probability, and we have proved the Bayes theorem. We have yes, we have proved the Bayes theorem. So, all these concepts we have covered in this video. So, thank you very much. I will be signing off now. We will meet in the next video and we will discuss more about random variables. That is the important concept in the complete probability theory. We will be discussing about the random variables, why we have to go for the random variables, and then what is the distribution function. So, next video we will be meeting. Thank you.